The title of section 5.6 in your text is Additional Probability Topics. The important things that we're going to be talking about from this section are what probability distributions are, the mean and standard deviation of probability distributions, and expected value. So this chapter is probably going to be split up into 2 or 3 videos. This one's going to be on probability distributions. First, we'll talk about what a probability distribution is. So the definition your text gives is that it's a distribution that offers the probabilities associated with all possible outcomes of an experiment. So basically what it is we will take everything that can possibly happen or all possible outcomes of an experiment, and it's going to associate those outcomes with the probability of each outcome. And remember how we talked about earlier that the probability of an event plus its complement equals 1 because one of those two things is guaranteed to happen. An important thing to note here is that the sum of the probabilities in a probability distribution is always going to equal 1. That's because we're including all possible outcomes, and if we look at the probability of every possible outcome and add them all together, it should add up to 1, which means one of the possible outcomes is going to happen. We don't know which one, but one of these things is guaranteed to happen. Okay, so first we'll look at one example, and then we'll talk a little bit more about probability distributions. So let's say here we're being told to write the probability distribution for the number of heads that come up when 2 coins are tossed. The first thing that we would want to do is write out our sample space so we know all of the possible outcomes and then so we can find the probabilities of them. Okay, so this is how we're going to set up our probability distribution. We're going to write down what our possible outcomes are. Right, and in this case, it's the number of heads. What your possible outcomes are can change depending on how the experiment is described, and then we want to find the probability of each possible outcome. If we go back to our sample space, we see, well, we can end up with 2 heads, we can end up with 1 head, or we can end up with 0 heads, right? We've looked at this before in, previous lessons. So we know we can end up with 0, 1, or 2. We know our probability of getting 0 heads is 1 out of 4. Our probability of getting exactly 1 head is 2 out of 4. And the probability of getting 2 heads is, again, 1 out of 4. Okay, so everything we have here is enough to write our probability distribution. We saw last time we could also take something like this and we could construct a histogram with it. That's another way we could represent a probability distribution. And another important thing to note, remember how we said all of the probabilities in a probability distribution have to add up to 1, right? If we do 1/4 plus 2 over 4 plus 1 over 4 again, we end up with 4 over 4 or 1, right? So this is one way that we can check our work to make sure that we didn't miss anything or maybe calculate probabilities incorrectly. Okay, so now we'll go back to talking about probability distributions. Okay, so probability distributions can be discrete or continuous, and we're going to talk about what these 2 terms mean. So we'll talk about discrete probability distributions first. In a discrete probability distribution, all possible outcomes can only take on a limited number of distinct values. And what we mean by that is that there have to be some type of gap between the values. So the last example that we saw was an example of a discrete probability distribution. This is because, let's say we're flipping 2 coins. We can end up with 0 heads, 1 head, or 2 heads, right? We can't fall on any value between 0 and 1, and we can't get any value between 1 and 2, right? It wouldn't make any sense if we were to get, 1.5 heads or 0.679 heads or 0.777 heads or something like that, right? We have to only have, whole number of heads. We can't have anything fractional like that. You can have a discrete probability distribution where possible outcomes can take on fractional values as long as they're limited and there's gaps between them that can't be filled. Although for this class, we're pretty much only going to be seeing one discrete probability distributions where the possible outcomes take on, whole number values like this. In a continuous probability distribution, possible outcomes can take on infinitely many uncountable values. And now what we mean by that is that you don't have gaps between the values. This is stuff we're going to see more when we get to chapter 6, but just to talk a little bit more about what we mean by when we say there's no gaps. Let's say our random experiment is picking a human being at random and we want to measure what their height is in inches. We know that they could be 60 inches, they could be 61 inches, but there's also infinitely many heights between 60 and 61 inches. If we were to try to measure you down to the, smallest atom, nobody is going to be exactly 60 inches or maybe exactly 61 inches. There's a whole bunch of other heights they could have that fit between here. It's not something like flipping a coin and counting the number of heads where you can only have a specific amount and there's nothing that can happen between here. With a continuous probability distribution, you can have all of these values between here happen. Okay, so that's the main difference between the two of them. Okay, now we'll go look at some more examples. Let's say we want to write the probability distribution for the number obtained when one die is rolled. So first, I'd recommend writing out your sample space. You don't always have to do this, but this will make things a little bit easier for us. Our sample space in this case is going to be the numbers 1 through 6. These are our only possible outcomes, and we know the probability of each one is going to be 1 out of 6, right? Because they all have the same chance of happening. Well, again, we would set up our little chart, right, where we have our possible outcomes. And in this case, our possible outcomes are the number on the die, and then we want to find the probability of each one. The probability of each one is just 1 out of 6. That's what we would write down for each one. And if we were to add up 1 6 times, it would end up adding to 6 over 6, which is equal to 1. Now we'll look at an example that's a little bit trickier than the other ones we did. It's a little bit more involved. Maybe you want to pause the video here and try to solve it yourself, and then I'll walk you through the solution. In this problem, we want to write a probability distribution for the number of green marbles we can obtain in an experiment where 1 marble is drawn from a bag containing 5 green marbles, 2 red marbles, and 8 blue marbles. So the first thing we'll do here is list out our sample space. Now, certain things are going to show up in the sample space more than once because everything in the sample space needs to have the same probability. So we have 5 green marbles. We could end up with a green marble 5 times. We have 2 red marbles. And then we have 8 blue marbles. And this gives us 15 equally likely possible outcomes. And now that we've listed the sample space, it wasn't required to list the sample space to do this, but it's nice to visualize things sometimes. We can now get to constructing our probability distribution. So we'll first make a column for the possible outcomes. And in this case, our possible outcomes is not what marble we get out when we take 1 marble out. It's specifically the number of green marbles that we can get. In this problem, we can only end up getting 0 green marbles or 1 green marble. We are just removing 1 marble from the bag out of 15 marbles that happen to be in this bag. And if we're only taking 1 out, well, if we get a red or a blue marble, that's not a green marble. If we get a green marble, that's 1 green marble. And that's it. Nothing else can possibly happen. So our probability of getting 0 green marbles when we take 1 out of the bag, if we look at the amount of red and blue marbles, there's 10 chances to not get a green marble out of 15 total. And then we have 5 out of 15 chances to get a green marble out of the 15 in there. And, we could reduce this to 2/3 and 1/3, but it's not, too big of a deal. Okay, so I think we'll end this video here, and in the next video, we're going to talk about the mean and standard deviation of probability distributions, and we may get into expected value.